Hello, everybody. I hope you had a good coffee break. Allow me to welcome our next speaker, Jakub Scholz from Red Hat. He will be talking about very interesting subject of storage in Kubernetes, and namely about stateful sets and what can you do when they are not enough. Thank you. It's all yours.
Thanks, and welcome everyone to my talk. My name is Jakub Scholz. I work as an engineer at Red Hat, and I'm one of the maintainers of the Strimzi project, and occasionally I'm also a contributor to Apache Kafka. If you never heard about Strimzi, then it's a CNCF incubating project, which is of course open source under Apache License 2.0, and it focuses on running Apache Kafka on Kubernetes. Apache Kafka, I hope you all heard about it, at least in some rough ideas. It's a stateful application, it's a data streaming platform or event streaming platform. It stores the data typically on a block storage. What we do in Strimzi is we provide operators to make it as easy as possible to run it on Kubernetes. We actually have several operators. One of them is kind of the main one for running the server components. Then we have some additional ones for managing the users and topics. And we have some more tools as well to kind of make it as easy as possible to use Kafka in the Kubernetes environment. What I will be talking today is kind of our journey where we started by using the stateful set as something what Kubernetes gives us out of the box. And then through different challenges and problems and limitations, we kind of over the years run into the situation where we left the stateful sets behind and we are not using them anymore. So how many of you have ever used stateful sets? Okay, that's almost everyone. I will just quickly go through some intro so that everyone knows what we are talking about. Stateful sets are basically a workload API which is part of Kubernetes, which is designed for running stateful applications. And saying it was designed for them is maybe a bit overstatement. It does two basic but very important things for the stateful application. It basically creates the pods with a predictable and stable names. So when the stateful set creates the pods which are running the actual containers, then the names are always based on the stateful set name and some index or some ordinal number. And these names don't change even if you delete the pod or if the pod restarts, the name will be always the same after a restart. So that's different from deployment where you have these random parts of the name and they change all the time. And actually in Kafka, this works quite nicely for us because we, for a long time, used to have two stateful sets, one for the Zookeeper cluster, which Kafka used kind of for bootstrapping, one for the Kafka cluster. Both Zookeeper and Kafka, they have their own kind of node IDs, server IDs, which can be easily mapped into the stateful set ordinals, and they are used as the IDs. And so that fits quite nicely. And the second thing which the stateful set does, which is very important for the stateful applications, is that it has this persistent volume claim template, where in the stateful set you can specify the template for generating the PVCs, the persistent volume claims, and when the stateful set creates the pods, it also creates the PVCs accordingly for each pod one PVC. So that allows you to, for example, have a stateful set which creates 5 different pods, and each of these pods has its own persistent volume claim and persistent volume for storing its data. So again, that fits fairly well. If you have never seen a YAML how the stateful set looks like, but from the hands up, I guess most of you have, then there is, as usually, the label selector for selecting the pods belonging to the stateful set. There are the replicas, which specify the number of the pods which will be created. Then there's the template from which the pods with the containers are generated. And then there's the template for generating the PVCs, which are then mapped against the pods and mounted into the pods. And when you create the stateful set, then you will see something like this, where Kubernetes take the stateful set and they create all the different pods, get them running. And you can see here the names. They are always name of the stateful set, -0, -1, -2, and so on. So that's kind of the basic stateful set. What the stateful set also supports are rollouts or rolling updates, which are important if you want to change how the pods are configured. So you can change the stateful set, and Kubernetes will by default kind of automatically roll your cluster, your stateful set, all the pods. And the way the rolling update works is that it basically relies on the pod readiness probe. So it basically goes, deletes the pod, starts the pod with a new configuration, waits for the readiness to be ready, for the pod to be ready. There are different timeouts and so on you can configure, but it's all driven by the readiness probe. And then once it's ready, then it basically moves to the next pod. And another thing which is part of it is that it does this always in a fixed order. So I think it used to start from the end, from the beginning, from the lowest numbers. Now I think it starts usually from the highest numbers. But yeah, it's basically fixed. Kubernetes do everything for you, and that's how you roll out any changes to the stateful set. And it looks something like this. So if you change, I don't know, some command in the container, you will see how the pods kind of one by one are deleted, started, get ready, and then the next one is rolled again until yeah, the whole stateful set is basically rolled. Now, in Kafka, we very quickly found out that this is not sufficient for us because we want to have our own order in which the pods are rolled, and we want to be in control of the timing under which the pods are rolled. This is, for example, because in Kafka, but also in Zookeeper, one of the nodes, one of the pods is always kind of a leader, and the other are followers. The leader has a bit special role. You want to roll it as the last one so that it doesn't kind of change during the rolling update every time the pod is deleted. And that's actually something what's quite common for many stateful applications. What's maybe not that common is that the way Kafka works, the readiness, if you see the readiness probe as when the clients can connect, then that's one thing, but then you have also the synchronization of the distributed data across the pods, where to maintain the availability, you want to wait for the data being in sync before you kind of move to the next pod. So that's what we wanted to do with our Kafka. And actually, this is quite easy with StatefulSet because the authors thought about these things, and there is this update strategy configuration in the stateful set. You can change it to on delete. And that means that when you change the stateful set, Kubernetes won't actually do anything by default. And it will basically wait for you to delete the pod, and only when you delete the pod, it will recreate the pod with a new configuration. And that way you basically control the rolling update because yeah, you can check all the pods. You see, okay, this pod with this ordinal, that's what I want to roll first. So you delete it, and Kubernetes created a new configuration. You wait for the readiness, it gets ready. But you can do additional checks to see whether everything is in sync or not. And only then you decide, okay, the next pod I want to roll is this one, somewhere completely else in the sequence. And this way you can control everything about the rolling updates. And it's great because that's basically part of the Kubernetes stateful sets design. And yeah, you can easily customize this. But then there are some other issues which you run into later if you are working on something like Strimzi. And they actually relate to the persistent volume claims. So as I said, the persistent volume claims is generated from the template which is part of the stateful set. But it means that by default, every persistent volume claim generated by it is exactly the same. They differ only in the name, which again contains the ordinal of the pod to which they belong and so on. And there are some situations when this doesn't work for us. So, for example, what was common request we got from our users is the ability to use different storage class for different pods, for the different PVCs. And the motivation behind it was that if you use different storage classes, you can use affinity configuration inside the storage classes, and you can do quite a nice trick around the scheduling the pods. You can quite easily lock the different pods to different availability zones and make sure that the pods kind of stick there, even if you have some rolling updates, that they don't mix between the zones and so on, which is quite useful in some situations. And here we start kind of getting into the gray zone. So what you can actually do is if you create the PVCs upfront from your tooling before you create a stateful set and just use the different storage class configuration, then, well, the stateful set, when you create it, it will see, oh, hey, the persistent volume claims are there, they have the right names, they look pretty much as I would expect it, let's use them. And it simply reuse these persistent volume claims for the pods, and everything seems fine. You have now different PVCs with different storage classes mounted into the different pods, and yeah, that's what we wanted. But this is now not exactly something what was designed for, and for example, when you need to do some storage operations like one of the volumes is broken, you want to delete it and recreate it again, then you can easily get into race conditions with a stateful set, because if you delete the pod and the PVC you originally created and try to create a new PVC again with your special storage class configuration, then suddenly the stateful set jumps in and creates its own PVC quite often before your operator can create the one you want. So you often have to kind of, for example, delete the stateful set without cascading, recreate the things, and then recreate the stateful set to get the pod recreated. So you can have some problems, you might need to deal with them. It's already a bit hacky. What's even worse is that in Kafka, it's quite common that you want to add or remove volumes to the pods. This is because Kafka was basically designed from the beginning with the idea that it wants to use just regular disks. It doesn't need to have any complicated RAID storage where you kind of create some huge virtual disks out of many physical disks. So it's quite common that you simply use multiple disks just to be able to store many and many terabytes of data in each Kafka broker. So you need to use multiple disks to increase the capacity. But sometimes it's also about performance, because with more disks, you get more throughput of the storage I/O. So it's quite a common issue, but unfortunately, if you would try to edit the stateful set and add additional volume into the template for the PVCs, then what you will find out is that it's read-only. Kubernetes don't allow you to change it. So we tried, and yeah, of course you can hack around it to some extent. So what you can do is you can do non-cascading delete of the stateful set. Non-cascading means that the pods will remain there as they were, still running, but the stateful set will be gone. And then you create again a new stateful set where you add or remove the volume from the template. And again, in our case, we would pre-create the PVCs first, but that's not that relevant here. But what would happen is that then you would have the new stateful set with the change disk configuration, and you would have the old pods. So now you would need to roll them to have the new configuration. You can do that again, but actually this time you cannot do the custom order in which you roll them. You have to roll them from zero, otherwise Kubernetes, the stateful set controller, will just start spitting out some errors if you try to do that from the middle somewhere, because it will simply not be able to reconcile the different volumes configuration in the pods and in the stateful set. So again, we were able to work around it. It was very important for us, but we are getting even more into this kind of, it's more of a hack than how it was supposed to be used. So we solved that one, even through maybe a bit hacky way. And the next thing we were running into were the custom ordinals. So originally, when Strimzi started 5 or 6 years ago, the way the stateful sets always worked is that the index numbers, the ordinals started at 0, and then they continued up in a sequence. So if you had 3 replicas, it was 0, 1, 2. If you had 5, it was 0, 1, 2, 3, 4. In, I think, Kubernetes 1.27, this changed a bit. So you can now configure the starting index number. So you can, for example, say, I want the index numbers to start at 10, and with 3 replicas, you get 10, 11, 12, and so on. You get the idea. And this ties also to the scaling up or scaling down of the stateful set. So by default, what happens when you scale up or scale down the stateful set is with scale up, it always creates a pod with the kind of next highest ordinal number. So if you have the 10, 11, 12 and scale up, it adds pod with the ordinal 13. And if you scale down, then it actually goes again from the back. So it will remove the highest pod with the highest ordinal. You can actually hack around a bit with this, this option to change the starting ordinal. So if you go edit the stateful set and you, for example, increase the replicas number, but also change the starting number from 10 to 9, then what would actually happen is that the new pod which will be created will be on the beginning. So it will be the 9. And similarly, if you want to scale down from the beginning, you can kind of edit it, scale down the number of replicas, and at the same time, change the start ordinal, and again, it will remove the pod from the beginning. But you never can really remove the pods from the middle. So if you have the pod 0, 1, 2, you can't say, let's remove the pod with the ordinal 1. And sometimes this is quite important in Kafka because you have terabytes of data on each broker, and sometimes, I don't know, you are decommissioning some project which didn't succeed, and most of these data are on the broker somewhere in the middle. So you want to save all the effort and time and just delete the broker from the middle. It would be easy, but it's not really with stateful set. But to be honest, when the users started asking for this, we were like, no, that's not worth it. In Kafka, you can actually use something called rebalancing, where you kind of reshuffle the data between the brokers. And you can kind of say, okay, the data I want to delete, they are in the broker in the middle, but let's move them to the broker at the end, and the data from the end to the middle, and then delete the broker at the end. And it will cost time. Sometimes it will cost money because of the data transfers and so on. But yeah, this was something where we said no, and we basically didn't implement this for a long time. But then what happened to us was this idea, let's remove Zookeeper from Kafka. It's something called craft. It basically means that the functionality which Kafka was using from Zookeeper is being implemented in Kafka itself. And the Kafka, it won't be anymore that we have the Zookeeper nodes with the Zookeeper cluster and the Kafka nodes with the Kafka brokers. We now will have only the Kafka cluster, or we actually, it's already implemented, so we already have it. And some of these nodes, they will be these controllers, some of these will be the brokers, some of these might have both roles at the same time. But what it means for us that it creates this asymmetric configuration problem, because the controller needs to have one configuration, the broker needs to have another configuration in terms of some Kafka configuration file. But also, the controller itself typically doesn't need that much resources, it doesn't need that much storage, whereas the broker that typically has quite a lot of memory, quite a lot of CPU, and huge amounts of storage. And this is a problem because with stateful set, all the pods are created in exactly the same way, so they will look the same. And when it comes to the configuration of your application, you can kind of play around it, right? You can have a config map which has 10 different configuration files. You mount this config map into each pod, but then inside the pod you kind of decide, okay, my pod name has the number 5 in the ordinal, so I will use as a configuration this file with the index number 5. But you can't really do this with the things such as the storage or the resources, because you can't say this pod number 5 should have just 1 CPU and 2 gigs of memory, whereas this pod number 6 should have 12 CPU and 64 gigs of memory. So this was kind of the thing which kind of broke us, and we started thinking a lot more, is it really worth using the stateful set or maybe not? What should we do about it? And we considered some alternatives. One of the things which we thought about was using a stateful set per pod, which would create these kind of weird pods, for example, my application 0-0, because we would have kind of some index in the stateful set name, then the index will be added from the pod name created by the stateful set. So that might work in a way, but it would look a bit weird. We considered some other tools which already kind of try to aim to replace the stateful sets. There's this project called OpenCruise, which has these advanced stateful set or clone set resources which kind of try to solve some of these issues. And What we also considered was that maybe we can manage the pods directly ourselves. At the end, if you follow the explanation, the stateful set doesn't do that much for us, right? We create our own PVCs. We don't really rely on the templating from the stateful set. We do the rolling update ourselves by deleting the pods. For various workarounds, we need to delete the stateful sets all the time to kind of work around something being read-only. So it seemed like the only thing we were missing was actually creating the pods. And so that's why we were really thinking about it, and does the stateful set really give us something, or are we anyway doing everything on our own? And yeah, that's the question, right? Is it just this what stateful set gives us? And I'm gonna now switch to a demo. So what you can see here is that I have already running cluster. I have here the Strimzi operator installed. Here I have the Zookeeper nodes. I'm still using the Zookeeper-based cluster. Here I have the Kafka nodes. This is kind of the user and topic operator for managing the users and topics. And if I go here, then if I do kubectl get stateful sets, you can see that there are no stateful sets anymore. So I'm not using the stateful sets. And let's see what happens when I delete one of the pods with the Kafka broker. Not here, I have to paste it below. So kubectl delete pod my cluster Kafka 1. I delete it, and what you can see here, it terminates, but it is immediately recreated. It gets running, and now we just have to wait like 15 seconds for it to get ready. And everything will be fine, right? Because the Strimzi operator saw that the pod was deleted, and it basically just went and recreated it, and that's how it does the job. But now let's try to see what happens if I do kubectl delete deployment Strimzi cluster operator, and that deleted the vol operator which was running there. And now I can go again, and I can delete the pod. And now you can see that it terminated, but nobody is starting it up again anymore, right? And this is just the deletion of the deployment was really just an example, right? You would probably not delete it, but imagine someone decided to optimize some RBAC rights on your cluster and deleted some cluster roles they thought were not needed, but were used by the operator, and it doesn't have the access rights. Or imagine that you are running in AWS, one of the availability zones crashed, now the operator was running in this zone, and it cannot be started because you don't have free capacity right now, and it's not running for that reason. So basically, if you start managing the pods yourself, it means that you are the one responsible for creating them. And in my opinion, that's a huge responsibility which you need to be really careful about. And for example, in Strimzi, until we were managing the pods ourselves, we didn't really need some high availability in the operator, right? The operator was running, it was managing the Kafka, but when it came to some evictions during draining of the nodes or during some availability zones, disasters and so on, it was Kubernetes who managed to recreate the pods. And that meant that if the operator wasn't running for several minutes, it was actually not that a big deal. But now, responsible for the pod creations, it's much bigger deal suddenly. And you have to kind of take into account the difference between the Kubernetes used by thousands, 10,000s, hundreds of thousands of people every day. They all use stateful sets on all different Kubernetes distributions. They all test it, make sure that it works, right? And Strimzi, I think Strimzi is pretty popular. We have thousands of users as well, but like we don't really have the same capacity. We don't really have the same scale of the users to test these things. So you can much easily run into various issues. For example, at one point, the Kubernetes client we were using had some compatibility issue with some Kubernetes distributions where, for whatever reason, some Kubernetes environments badly terminated the WebSocket. the Kubernetes client didn't handle it, didn't reopen it, and it caused that the informers we used to find out that the pod was deleted were actually not aware that it was deleted, and they saw it as running and they didn't do anything. A big problem, right? And if it was StatefulSet, probably someone would have solved it before. With Strimzi, you then get very small percentage of users reporting this from their environments. You have to somehow get the logging, try to kind of figure out what the issue is, eliminate what the environments are where these problems happens, and you need to solve this. So that's kind of part of the responsibility, what you get out of it. So just to give you some more insights on how exactly we got rid of the stateful sets in Strimzi is we actually kept the way quite similar to how it was when we were using the stateful sets. But instead of stateful sets, we created our own internal resource called Strimzi pod set. And the way this resource looks like is that it's basically a custom resource which contains a list of the pod definitions as they are. There are no templates, no persistent volume claims, it's just pod definitions. And then we have a separate kind of thread class object in our operator, which is responsible for creating these pods. And that's really helpful for us because that allows us to kind of separate the concerns. It makes it easier to test these things because you can kind of test it separately from running some big Kafka cluster. And it allows us to kind of work in the same way, and it helps us to kind of improve this reliability, because if we would do it in the main reconciliation loop of the operator, and imagine you have the reconciliation loop running, it's connecting to one of the Kafka nodes to kind of do some management operation, then there's a worker node crash and this pod disappears. The TCP connection remains hanging for, what, 30 seconds, minute, then it timeout. So like having these separated concerns that allow us to be kind of able to quickly react to the pod deletions. So I think that worked great for us, but it's not necessarily something what has to be copied. I think that's to a large extent defined by how our operator is designed and how the code works internally. And maybe for other tools and other operators, it can be simply done from the main reconciliation loop. Right, so just to give you an idea, this is how the YAML looks like for the Strimzi pod set. So what you can see here is there is the selector as normal in StatefulSet, but then you have this, this pod list, which really contains just the list with the pod definitions. You can see there just the comments so that it fits onto the screen, but it really contains the full pod definition with everything. There were some other disadvantages and issues we ran into while getting rid of StatefulSet. So some things work a bit differently if you have pods managed by a standard Kubernetes controller and then you do it yourself. For example, for whatever reason in the pod disruption budget, you can't use this max unavailable option when you manage the pods yourself, but you have to use the min available option. We had also some smaller issues with various tooling. I think some cluster auto-scaling tools had problems when the pods were not managed by some stateful set or deployment when they were trying to evict them. And I think some specific Argo CD configurations had some checks for stateful sets, and when the pod was not managed by the stateful set, it suddenly decided to delete the persistent volume claim despite it looked exactly the same as with the stateful set. And yeah, as I said, you have to keep in mind that you also rely on the Kubernetes clients, you rely on all the different Kubernetes distributions running out there, you rely on the different configurations of the Kubernetes API server and so on. As a conclusion, so just to be clear, although I talked about some problems with getting rid of StatefulSet, I don't think we have any regrets for getting rid of it. I think we are quite happy with it, and I'm not aware of any problems being reported or anyone having some significant issues with it. That said, StatefulSet is a great starting point. So maybe if you know already upfront that you will be running into these same limitations as we were and you really will need to solve them, then maybe you should just skip them. But otherwise, they might be the best starting point for you. And Yeah, also I covered various different limitations which they have, and I'm quite sure other applications might run into other limitations. Then still, I think it's a huge responsibility you would take over from for managing the pods. So you should be really careful about it, and you should really consider whether that's worth it or not. And yeah, that's it for this talk. And we should have some time for questions. And I can see some on the screen here. So the first one is this strategy now part of the best practices blueprint Strimzi now advertise? Or, oh, you just deleted it before I managed to read it. But so I think if I remember correctly the question and got the idea, then, okay, it's back, no. Yeah. Or is it just a way to grant full control over your Kafka cluster? So the way Strimzi works in the current versions is we don't support StatefulSets and we don't use StatefulSets at all. So whenever you use the recent version of Strimzi, you are using this mechanism and you are using these Strimzi pod sets. The idea is that you should not really care about it, and there is still kind of upgrade logic. So if you are upgrading from some older version, there's kind of a logic how to smoothly migrate the pods managed by the StatefulSets under the Strimzi pod set. But otherwise, basically, when you use Strimzi today, then Strimzi manages the pods directly, and it's used out of the box, and there's no other option with Strimzi in the current versions. So I hope that answers that. The next question is, in Kafka with Craft, there will be no special nodes for brokers. Craft controllers will share the nodes with them. So there are different architectures which are possible. If you are more interested into the topic, then I had a talk about this at KubeCon in Paris on Data on Kubernetes Day, or I will actually do a similar talk next week in DevConf in Brno if you are planning to get there. But basically, you can have a dedicated controller node and dedicated broker node. So that would look pretty much like with Zookeeper, where you have some nodes which are responsible just for the quorum and metadata management, and some other nodes which are responsible only for the brokers. You can also use mixed nodes where you have the nodes doing both things at the same time in a single kind of JVM, in a single process. These kind of are best suited for different architectures, different patterns, different environments, but you can use all of them. But in any case, kind of the sequence numbers of the nodes, the node IDs, are still from the same sequence. So you will, for example, have controller ID 0, controller ID 1, controller ID 2, broker 3, broker 4, broker 5, and you cannot have controller ID 1 and broker 1 as well, because that would create the conflict. So I hope that helped to answer this one. Then the next one is for the high availability, didn't we have problem with the operator down already with the StatefulSets because of the custom persistent volume claim pre-creation? Maybe in some cases it was a problem, but in general, if you were facing some worker node evictions or availability zone crashes, then in general the PVCs stay there, and they were still used by the pod for the good or for the bad. So I don't think there were any major issues with this. Then the next question is, what are some of the pain points you have encountered once adopted Craft and moved away from Zookeepers? That's probably for a long discussion we should have had yesterday over the beer. I think there's still a lot of missing features, and the quality of Craft is, to be honest, a bit lacking. Yeah, there are still a lot of challenges, but definitely this kind of dealing with the different architectures, being able to change the roles for the brokers, that's definitely one of the big pain points for me as the operator developer. But hopefully once it will be all finished, it will be all great and smooth for all of us, because to be honest, I don't know many people in the Kafka world who are big Zookeeper fans. So, and the last question is, Have you considered extending Kubernetes core StatefulSet API as an alternative to creating own pod set? Yeah, we considered it, but it's, to be honest, quite hard because if you would want to do some changes, you would need to do a lot of discussions, a lot of proposals. Everything takes a long time. Then it's probably introduced maybe as some disabled feature gate, and you have to wait for it to be enabled everywhere. And the rollout would be huge and really long. And the Kafka community with the Kraftwerk and so on, that doesn't wait for us or for Kubernetes to be better prepared for this. So yeah, it's it would be nice to over time get some of these things into the StatefulSet API as it's evolving, as I mentioned, for example, these start ordinals. But yeah, I don't think that would be done in time. And also at the KubeCon in Paris, actually, there were several other people around different stateful applications, around ClickHouse and databases, who pretty much share the same issues, and pretty much all of them solved it by working around the stateful set and not using them, or by some of them not using them at all from the beginning. And I think that's it for the questions. So thanks for being here, and hopefully the talk was useful, and enjoy the rest of the conference.